Okay, so the topic that we'll be doing today is quadratics. And from quadratics in our previous video, we understood how to complete the square. Today, we are going to understand why do we need to complete a square. If I give you an expression y is equal to x squared plus 2x plus 5, and I ask you the maximum value or the minimum value of y, it's very difficult for you to tell me that. Why? Because when you put the values of x in both these places, in place of this x where you are going to square it, and in this place where you will multiply it by 10, multiply it by 2, and eventually you'll get your final answer by adding 5 to the entire output. But once you complete the square for this, how do you complete the square? We have already watched it in the previous video. We take the 2ab, which is 2x, and we divide it by 2a. 2 is a number and a is simply x. We get our b, which is 1. We add the square of 1. We subtract the square of 1 and we have plus 5. Now, once we have the value in this way, now remember it's the same quadratic expression. Now it has just been, the square has been completed for this one. We have written it in the completed square form. Now for squares, we are sure that squares are never negative. For real numbers, squares are never negative. So I know that the square is either greater than or equal to 0. Now once I add 4 to it, that means that the minimum possible value of y can be 4. Why? Because the minimum possible value of the square is 0. So the minimum possible value of y is 4. So if I were to understand it through the graph, the minimum possible value of y is 4. And that is so when the square is 0. How can I make the entire square 0? If I want, just let me write it, minimum and when the square is 0. So the x value has to be -1. So we can say that the quadratic, the turning point or the coordinates of the vertex are simply -1 and 4. These are the reasons that we need to complete the square for. Once we have the things in the completed square form, we can write it in this particular way. We will say that if there are two things that we can extract out of this form. The first thing is that if a is positive, we get a happy face quadratic, which means that there will be a minimum point. And if a is negative, we get a sad face, which means that the quadratic will have a maximum point. Common name for a minimum point or a maximum point is a turning point or a stationary point, and that can be extracted if the equation is written in this form by writing it h comma k. So this is the primary advantage of converting any quadratic equation from an expanded form into a completed square form. We know the entire shape of the quadratic graph, whether it's a happy face or a sad face, or it has a maximum point or a minimum point respectively, a minimum point or a maximum point, and we can also figure out the coordinates of the turning point.